Hello, welcome to Algorithm. Today we're going to be solving Leetcode 1249, minimum remove to make valid parentheses. In short, this question asks you to remove the fewest number of parentheses to make the string valid. And the string is valid if all open parentheses are closed in the correct order. So, when you encounter these kind of problems where you have to check the validity of parentheses, it might be a bit overwhelming, but this is a very typical LeetCode problem pattern that you can recognize. And typically, these problems are solved using stacks. Parentheses and expressions are inherently nested, meaning that if it's like this closed parentheses will look for the most recent opening parentheses. And a stack is perfect for dealing with such nested structures because it operates on a last in, first out principle, mirroring how nested parentheses should be matched. For example, to simplify things, let's look at the given example. Now, the question requires to check if the string has valid parentheses. Therefore, I'll be, for now, ignoring all the rest of the strings that are not parentheses. So this will become like so. So in order to deal with this, we first notice how we have an opening parentheses right here. Then we add to the stack. And then we add another stack here when we're here. And then we come here to a closing stack. And we see that on our stack, we have an opening parentheses. Therefore, we pop this out and we go to the next one. Now we come to another closing parentheses and we check our stack and there's another opening parentheses. Therefore, we pop this out and we go to the next index. Now, when we're here, there's nothing on the stack. Therefore, this is an unmatched closing parentheses. Therefore, we must get rid of this parentheses. Now, in the given example, we had unmatched closing parentheses, but that's not always going to be the case. We can also have a case where we have unmatched opening parentheses. For example, like this, you can clearly see that this parentheses is not matched. Therefore, the way we check this is we'll be iterating through again. We'll add this to the stack. We move to this one. We add another one to the stack since it's an opening parentheses. We go to the next one, then we'll add another one. And then we come to this one, we'll pop this one out. We come to this one, we'll pop this one out. And we see that this is invalid open parenthesis that has no match. Therefore, we have to get rid of this on this string. Now, this is how the code in general will do. Before we get into the coding, I kind of want to mention something that's very important to this question. Not just this question, but these types of questions where we have to check valid parentheses. It's about strings. String operations such as string concatenations are very taxing to the programming language that have string as immutable. This is because, let's say we have a string variable of a. When we add b to it, instead of adding b to the existing variable, we're making a completely new variable, saving it in a separate space. So this is still stored somewhere in the memory. Now we're going to make a new string. Look at what a was. Bring it to the new memory, and then look at what we're trying to add. We're going to make a new space for b when we already have made one, and create a new string, basically. This is why It's very important to avoid string concatenation if possible. So the code solution that I have come up with will try to avoid string concatenation and therefore solve in a very odd way if you look at it at first time. This is because we are trying to solve the question using list operations, because list operations, we can control how it's added and therefore control the time complexity better. So let's go to the coding part of the question. In order to solve this question, we're going to create a new string, which is like list. We'll operate on it, and then we'll return the new string with the join operation to the new string. This way we'll avoid any string operations to save time complexity. Now we're going to use our stack. My stack equals this. This is the stack that will keep track of the indices of where the parentheses are. Now we're going to iterate through the string. When we're iterating through, we're first going to add every string into the string stack, and then if current character is open in parentheses, on our stack we'll add the indices of our current string. You'll see why I'm doing it this way soon. And if it's a closing parentheses, we'll check if our stack is empty or not. If it's not empty, we will pop our stack because it's a valid string, valid parentheses. If not, we'll be editing our current string to nothing. Now, this is important. What's happening here is we're going to change the current index into current string, which is the closing parentheses, into nothing. And when we later join, there'll be nothing in the element, so therefore it will just skip over when it's trying to join and make a new string. This is the way we're going to get rid of any unmatched closing parentheses. Now, that's the whole operation. And we have to consider the case where we still have unmatching opening parentheses. So we'll go over the stack if there is some stuff left. And then because we added the indices of opening parentheses, we can just go to our new string stack and get the indices and turn them into an empty character. This way, every unmatched open parentheses will become clear characters. Now we'll have characters like, we'll have a list of characters like such, a list like this, maybe this will be a matching, something like this. Now this, we can tell the original string was something like this, or like that, where it had the unmatching thing and we got rid of it. Now when we join it, we'll get a string of A, B, right? this is coding part of it. This is very simple. It's comparatively a lot simpler than what the question asks once you figure out that you gotta use stacks, and make sure you find a way to avoid from using string concatenation. And if I run it, whoops, I have to use my stack here. And lo and behold, we have passed the, the test with flying colors. Thank you very much.